Hey all, till now what we have done is we have used this particular PCB to create a platform to insert a microcontroller IC here, comparator IC or sensor IC here, and motor driver IC here. Now to all these units we need power supply. That power supply unit I am going to design it here. So this power supply is a DC regulated power supply. The supply required for microcontroller and other units is about 5 volts. Using this circuit we are going to generate, right? So this is the power supply unit. This is a 9 volt simple rechargeable battery it is, which is available in the market. We get a connector. With this we can connect the battery in this particular manner, positive and a negative terminal. We'll be applying the positive terminal of the battery here and a negative terminal of the battery. I'll be using a regulator IC with name 7805. It means that it is a positive series regulator IC with the output voltage of 5 volts. This is that component. Now this component has 3 terminals, terminal 1, 2 and 3. Terminals 1, 2 and 3 are connected in this particular format. The input is applied at terminals 1 and 2, where terminal 2 is the ground which is common between the input and the output terminal. Terminal 3 is the output voltage from where we observe a DC output supply. These are the terminals of a 7805 IC. This regulator generates an output of 5 volts. Now I need some sort of physical indication to see whether supply is coming to the circuits or not, making use of a LED and a resistor. Let's solder this entire circuit on this platform available here. I'll be inserting this component somewhere here, the LED, as this is the positive terminal, right? So I'll be inserting that LED somewhere here like this, a resistor from the other terminal and connecting it to the pin number 2, where pin number 2 is the ground line. This is how we connect it. So I'll be soldering these components. Now these 3 terminals are soldered here as 1, 2 and 3. I'll be shorting this another end of the resistor manually with the ground terminal here, which is shorted now. The other terminal of the resistor is here, which is connected to the negative terminal of the LED, which is here. Let us short these 2 terminals together, which is done like this. This completes the soldering process. Now the remaining leg ends are there. We need to chop these leg ends down. I will be using cutter and I will be chopping these leg ends here, somewhat here like this. This is the PCB design implemented. This is how it looks after the design. What we have done here is, at the background, it is simple. Assume this to be as entire PCB design and we are somewhere here. We are somewhere here, right? I have 3 holes here. At these 3 holes I will be inserting a 7805 IC, right? So here these 3 holes I have inserted the 7805, right? 1, 2 and 3. After this, what I have done, I have inserted a LED like this here. In these 2 column I have inserted a LED, positive here and negative here on this line. I have inserted a resistor from here to here. I have a resistor connected in this direction. Now the connections are made in this particular direction. This is the input, this is soldered out. These 2 are shorted, these 2 are shorted and these 2 are shorted. Similarly, that can be observed here. This dot corresponds to this line here, negative and the terminal. This represents the output connection of the 7805 with the LED. The other center line represents the connection between 7805 ground and another terminal of the resistor. Another terminal is kept open. Now we'll be connecting the battery snap to this particular circuit. Both the terminals are soldered so that I can place the component. This is the positive terminal. Pin number 1 goes to the positive terminal here. Pin number 2 goes to the second terminal like this. Now we need to solder these legs. At the end of soldering, it should somewhat okay. Now let us check this circuit is working fine or not. Let's give some DC supply to the circuit and we'll see whether the LED glows up or not. See, these are the terminals. I need to map it in this particular way and the LED turns up. So it means that the circuit that we have designed is providing a 5 volts of DC supply, and we are able to get a DC output voltage of 5 volts here.